All right, so the next lesson is on something called the normal distribution. Okay, so the past two lessons, what we've been dealing with is a statistics, and we're trying to find the mean, median, mode, the range, and the standard deviation of what we call a sample. Right, that's when you have like certain measurements, and you can calculate those statistics. Now, what we're going to be doing is we're going to be looking at what we call a distribution, and this applies to what we call something called a population. Okay, so a population is like all the people or all the things, whereas a sample is just like like it is what it's called a sample, sort of like a snippet of that population. All right, so yeah, so that's just one thing I want to point out here is like we might have a population of people or with certain characteristics, and then within that population, we take a sample to make some measurements, and then with samples, what we can do is we can draw a conclusion about the entire population. All right, and one what they call a distribution is basically is when we take a count and basically we tally it up, and so what ends up happening is this is a special type of distribution where it's called a normal distribution. So you can see it's kind of like a bell curve, where right in the middle is the most people, all right, or most things. So this in the middle is what we call the mean. All right. um, so a couple things about a normal distribution is the mean. And the mean is used, the symbol that's used for the mean is this Greek letter called mu. So the mean of the population, right, is in the middle. And the other thing about a normal distribution is it's symmetrical. Okay, so it's sometimes called a bell curve. All right, so basically what happens here is that if we take like some examples of normal distributions, first one here is heights of a population. Okay, so I'll kind of explain maybe with the context of this, it'll make it a little bit clearer what's happening. Is that if we took all the measurements of all the heights of a population, the average height would be the most people, right? So that's why in the middle here would count to the most, and then as you go further away, the less and less people will be that tall. All right, or less and less people will be shorter. Okay, so this is like indicating the middle, and then let's say we go 1 inch one way, there's going to be less people, and then so forth and so on. All right, so what ends up happening is this bell curve. So one example would be the heights of a population. Another one would be these I just kind of Googled the IQ score. So most people score the average IQ is 100, and then as you get further away from the average of 100, you get less and less people. Shoe size is another one, and birth weights. Right, so when babies are born, there's an average weight, and then if you count the heavier babies, there's less and less, or lighter babies, there's less and less as well. Okay, so what ends up happening is you get this curve. So this is called a normal distribution. All right. So with the normal distribution, there's a rule. It's called the empirical rule, but you don't need to know that. It's mostly known as the 68, 95, 99.7 rule. Okay, so the 68, 95, 99.7 rule is basically it tells you the percentages of the population that are one standard deviation away. Third deviation. So one standard deviation away from the mean will be 68% of the population. Okay. Now standard deviation, the notation is the sigma. All right. So one standard deviation away from the mean will represent 68% of the population. Okay. So if that's the case, then what that means is that, again, the mean is in the middle. If I went one standard deviation to this side, it's going to be 34% because that's half of 68. All right, so yeah, so what you'll notice here is that, let me scroll this down a little bit, 68%, what it's saying is that 68% of the population is within one standard deviation. Okay, so that means 34% would be bigger than the mean, and 34% would be less because that's a total of 68. Within 2 standard deviations, so I'm just going to write 2 standard deviations like that, you're going to have 95% of the population. All right, so what you notice here along the bottom here, it says the mean minus 1 standard deviation, mean minus 2 standard deviations. So if I took the measurements from 2 standard deviations less to 2 standard deviations more, these kind of 4 sections here should add up to 95%. All right, so yeah, so if I have 34 and 34 there, if I add another 13.5, right, this side here would be 47.5%, 47.5% on that side, so for a total of 95%. And the third one here, the 99.7, means that there's going to be 3 standard deviations, right, from the mean. Okay, so yeah, I know this is a little bit abstract, a little bit weird. So what I'm going to do here is do an example. I think this will be a lot more clear. All right, so I'm just kind of laying out the kind of like the theoretical rules, all right, for this normal distribution. But again, through an example, I think that'll make more sense. All right. So what I'm going to do here, I'm going to use the kind of like IQ as a example here. So for the general population, IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. And what we're going to do is we're going to construct a Bell's curve. Right. So we're going to construct one of these graphs kind of things with the probabilities, and we're going to answer the following questions. Okay, so down here, it just asks for a bunch of percentages. Okay, so the key thing to this is to actually, construct the bell curve. All right, so I'm just going to draw a kind of a rough, big bell. So I'll try that again. All right, so draw a big curve, something like that. All right, so and again, right down the middle here is the mean. Okay, so this is the most people would score 100 on the IQ test. Okay, now since once standard deviation is 15, if I add 15 here, this will be 115, and then over on the other side here, if I subtract 15, that's 85. Okay, so basically what I did here is I just added this 1 standard deviation to it, and I subtracted 1 standard deviation. Okay, so from 85 to 115, that's within 1 standard deviation of the mean. Okay, so 1 standard deviation on both sides. Now the rule was it's 68%. So I'm just going to write the rule here: 68, 95, 99.7 rule. All right, so if it's 68% total between these 2 sections, that means that we have 34% in this side, as well as 34% on this side. Okay, so this again is an approximation, kind of a general kind of rule. Okay, so within 1 standard deviation of the mean on both ends, it's 68% total, which means it's going to be 34 and 34. All right. Now, if I go another standard deviation, I'm just going to mark it off here and here. Just fix this here. All right, so if I add on another standard deviation, that would be an IQ score of 130, and over on this side, it'd be an IQ score of 70. All right, so to fill in these blanks, I could scroll up and look at the graph that I made, but I think it's kind of important for me to show you actually how to construct this by hand. All right, so 95% would be these 4 sections. Okay, so if I take 95 and minus the 68, we actually have 27% left over. Okay, so what that means is that this section plus this section must add to 27, which means that if I divide this by 2, each one of these would be 13.5%. All right, so I'm going to just write that in here: 13.5 and 13.5%. Okay, so that's how we get those numbers in the previous graph here. So if you notice here, it says 13.5 and 13.5. All right, now I'm going to do the same thing to get these 2.35%. So I'm going to mark this off again to here and here, and we'll call this 145. This would be 55. Right, so I'm just subtracting 15 and adding 15 on both sides. So that's 99.7%. All right, so let's just pull up that calculator. I got 99.7 minus, all right, so this is 95% between these four sections. So if I subtract 95, I got 4.7%. Okay, so that means that this section here must add to 4.7. So I'm going to divide that by 2, and we do get 2.35. Okay, so within this little section here, this represents 2.35% of the population, and this side over here, 2.35%. All right, and then lastly, the end pieces. All right, so there's still a little bit left here over on this side and this side. Okay, so the key thing to figure out, actually, you know what, I'm just going to draw a line on the bottom here. All right, so the key thing to remember here is that everything underneath this curve is 100%. Right, it's 100% of the population. So if everything adds to 100, if I take the 100 and minus the 99.7%, I have 0.3% left over. Okay, so again, I took 100% underneath the curve minus the 99.7%, which is these sections here, what they add to. That's what's left over is 0.3. So if I divide that by 2, I got 0.15 left. So that means this section here is 0.15%. So very small percentage as well over here. Okay, and if you notice here, what I'm going to do here is just kind of scroll up to this diagram here, and you can see that these numbers actually do match up with the ones I just came up with. All right, so using the 68, 95, 99.7 rule, we can actually figure out what these percentages are. Okay, so scrolling back to the context of this question, what this means is, like, if I asked, you know, what percent of the population has an IQ of greater than 145, that would be this little section here, right? So that'd be 0.15%. All right, and so on. All right, so let's answer some of these questions. All right, so what percentage of the population scored between 85 and 115? All right, so from 85, just gonna use a red pen here. From 85 to 115, we already know through the rule that it's 68%. You can also add up these two here. All right, so the answer to this here is basically it's asking you how much of the population is within one standard deviation. All right, so that's 68%. Cool. All right, so basically I'm just going to use this bell curve to answer these questions. What percentage of the population is between 70 and 130? Okay, so 70 and 130. So that's from there to there. Again, you can see that this is asking, you know, 2 standard deviations to the left, 2 standard deviations to the right, and we know through the rule that it's 95%. Okay. The alternative way is to add up these 4 sections, and we are still going to get 95%. Okay, so the answer to this one here would be 95%. All right, next up, what percentage of the population scored between 100 and 145? Okay, so between 100 and 145, you know what, I'm just going to erase the 2 ones that we just did here. Oops, I didn't mean to erase the 85, so let me just write that one back. Okay, so so now we got to kind of add up them individually here. So 100 to 145, that's asking this section in here. Okay, so that'd be 34% plus, was it 13.5 plus the 2.35%. Okay, so basically to answer this question, between 100 and 145, I needed to add up these 3 here. Okay, so when we do that, let's just do that. So 34 plus 13.5 plus 2.35%. All right, so we get, that's not right. Okay, let's try that again. 34, 13.5, and 2.35. 2.35. All right, so 49.85%. is the percentage. All right. There's a couple of other ways we can actually do this as well. So let me just kind of talk you through some of those. The other thing is what we could have done instead is realize that from here on out, that's 50% because it's symmetrical. And so we can subtract this section here. So if I took 50% and subtracted 0.15, right, because the 0.15 here is not included in this in these three here. Notice that we do get 49.85, right, which is the same answer. I can think of one more way. The other way is if we did take this 99.7% rule. If I took the 99.7 and instead of going from 55 all the way to 145 as the rule, notice that we start at 100, so it's going to basically be half of the 99.7. So if I divide this by 2, again we get 49.85. Okay, so I can kind of figure out or kind of see three ways of getting 49.85%. Okay, all three ways is totally correct. Okay, so whichever way you prefer to figure that out. Okay, so hopefully those made sense. And the last one, what percentage of the population score over 70? Okay, so let me just kind of erase this stuff that we just drew in red. All right, so this last one here is over 70%. Okay, so that's indicating that percentage. We could add up all of these together. All right. We could also take the 100% and subtract this section, and go from there. Actually, you know what? I think I like that one. All right. So basically, what I'm going to do here is I'm going to take the 100% underneath the curve and subtract this section here. Okay. So 100% minus those two sections here. So 2.35% and the 0.15%. Okay, so I just subtracted those two sections, right? Because this whole underneath this whole curve is 100%, right? So if I subtract these two, I should have what's left over, which is what I'm looking for. So above 70, take 100% and subtract these two. All right. So let's do that. Okay, so 100 minus 2.35 minus 0.15. Okay, so we have 97.5%. Oops, what did that mean there? 97.5% would be your answer. Okay. Yeah, and I can almost promise you that you could also, add these up together. You're still going to get the same answer. All right, we got one more. What percentage of population score below 85? Okay, so below 85. Just erase that. Okay, so below 85 means what percentage is over here. I think the best way here is just to kind of add up these three values here. Okay, so I'm going to add up to 0.15, 2.35, so 0.15% plus 2.35% plus what's this one? 13.5%. Okay, so when we add those together, the total is 16%. Okay. Yep, so the answer there would be 16%. All right. Okay, so yeah, so this is basically just finding these populations, or sorry, the percentages through this bell curve. Okay, now these numbers here, these percentages will all be the same when we talk about standard deviations. Okay. In the next lesson, what we're going to do is we're actually going to not just look at the standard deviations. We'll just look at what percentage is, for example, what percent of the population is less than 105. We can do stuff like that using what they call Z tables. All right, but that was the next section. Okay, so this is kind of like an introduction to this normal distribution, just being familiar with this rule and calculating the percentages within like standard deviation markers, if that makes sense. All right, cool. So yep, so that's the normal distribution. Cool.